In this video, we'll use a step-by-step approach to detail XLMiner's neural network classification method. What is a neural network? A neural network mimics the neural structure of a human brain by processing records one at a time and learning by comparing the algorithm's classification of the record with the known actual classification of the record. The errors from the initial classification of the first record are fed back into the network and used to modify the algorithm for the second record. This process repeats for many iterations. The main benefit of a neural network is its ability to discern complex relationships between multiple inputs and an output. Here's a database containing 13 variables which measure the chemical attributes of wine samples from 3 different vineyards. The objective is to assign a wine classification to each record. First, we'll partition the data into training and validation sets. One very important issue when fitting a model is how well the newly created model will behave when applied to new or unseen data. To address this issue, the data set can be divided into multiple partitions: a training partition used to create or train the model, and a validation partition to test the performance of the model. Partitioning is performed randomly and according to proportions specified by the user. In this example, we'll partition using a standard data partition with percentages of 80% of the data randomly allocated to the training set and 20% of the data randomly allocated to the validation set. To partition, simply click a cell within your data set, then click XLMiner, Partition, Standard Partition. I'm going to choose to include all of my variables in my partition data. I'm going to leave Pick Up Rows Randomly selected under Partitioning Options. And under Partitioning Percentages when picking up rows randomly, I'm going to select Specify Percentages and enter 80 so that 80% of my rows are allocated to my training set and 20% of my rows are allocated to my validation set. Now I'm ready to click OK. The worksheet Data Partition 1 is inserted into the workbook. If you'd like to check out the 142 rows allocated to the training data, simply click this link. If you'd like to check out the 36 rows allocated to the validation data, simply click this link. Now we're ready to run our classification method. Simply click Classify, Neural Network. First, we'll choose our worksheet, which is Data Partition 1. My output variable will be my type variable. This is the wine type. This is what I'm going to assign to each of my records. I'm going to use the remaining variables as my input variables, and then click Next. I'm going to choose to create a manual network with 1 hidden layer and 25 nodes, and then I'll click Next to accept the defaults for the rest of the options. Now I can click Finish. Our results are inserted into our workbook. The top section of this worksheet includes the Output Navigator, which can be used to quickly navigate to various sections of the output. The Data, Variables, and Parameters/Options sections of the output worksheet all reflect our input choices. Let's scroll down to the confusion matrix. Here we see our confusion matrix for the training data. As you can see, no records were misclassified, which give us an error of 0%. So the neural network performed perfectly on our training data. Now if we scroll down a little bit further to our validation data, we see that 1 record was misclassified, giving us a total error of 2.78%. Still very small. If we scroll down a little bit further, we see our interlayer connection weight between our input layer and the hidden layer. And if we scroll down a bit further, we see the same weights between the hidden layer and the output layer. Now let's click the training epoch log link. Here we can see that the error in our training data set actually went up to almost 30% before steadily decreasing down to 0. Recall that there are 6 different classification algorithms to choose from. We suggest trying a few to find the algorithm that performs best on your particular data set. Moving from method to method is easy. Simply click the Data Partition 1 worksheet. There's no need to repartition. And then click the classification method of your choice. Let's select the classification tree method. Our output variable and input variables are the same, so we just simply need to click Next. We are going to choose to normalize the data. And I'll choose to select the full tree and the best prune tree. Again, we have our output navigator at the top and our input selections. Now let's scroll down to our confusion matrix. Here we see that in the training data, 11 records were misclassified, giving us an overall error of 7.75%. And in our validation data, we have 5 records misclassified, giving us a total error of 13.89%. Recall that the neural network was able to classify all records correctly in the validation set, giving us a 0% error, and only misclassified 1 record, resulting in an overall error of 2.78%. Clearly, the neural network performed the best on this data set. As you can see, 142 cases went into the tree, 52 split off to the left, 90 off to the right, and for our validation data, 36 cases went into the tree, 19 split off to the left, 17 split off to the right, and so on. For a graphical representation of the full tree, simply click the full tree link. And here's a graphical representation of the tree. Here's our 52 records going off to the left and our 90 records going off to the right. Hover over a decision node to see the rule. Click the Prune Log 1 worksheet to show that in our validation set, a tree with only 2 decision nodes gave us our best error, 13.89. And here's a graphical representation of that tree. Again, we can hover over decision nodes to view the rule. Let's go back to our neural network since it performed better than the classification tree, and let's run our network on 9 unclassified wine samples. To run our neural network on these 9 new unseen records, simply click Score, choose the correct worksheet, and data range. Choose the NNC Stored 1 worksheet, which is where our model was stored, and then click Next. I'm going to match variables with the same names and both set, and then click OK. Let's take a look at our first record. Here we see that for our first record, the probability that this record belongs to class A is about 14%. The probability that this record belongs to class B is about 86%. And the probability that this record belongs to class C is essentially 0. This is why the predicted class B was chosen. This ends our discussion of our classification method. These methods can also be applied to the classification of good or bad credit risk, fraudulent or normal credit card transactions, classifying malignant or benign tumors, etc. If you'd like to contact technical support, please click the link that appears on the screen now.